So, hello friends, my name is Rashid Sati, and me and my teammates have made this project called Vista Ways, which is basically an AI assistant to chatbot, which is used to guide people or users to the locations where they can visit and much more. So, this is our page on Kaggle, and this is how our code looks like. So first of all, we have installed some important packages over here, as you can see, and we have add few more dependencies to the code, and we have imported few libraries like you can see over here. This is a library in Python called Pandas. So our code have downloaded all the dependencies inside the library, and next we have imported few more important libraries as you can see here, like import request, import numpy, and much more like all these. Then we have set two API keys. We have used two API keys. One is Google API key, and second one is weather API key. Google API key is used to get responses from the Gemini, but we have used our own data inside the code. Second, we have created a data like for OpenStreetMap. So we have created this code for our data. Like this is how our data will look like inside the code. It will have all the directions as well. Like our data have historic places, adventurous places, and much more. And this is bounding box visualization. It show you the exact region where you can visit. It have a map which includes a political borders, state for the better context. A, a map is located inside a bounding box, and all the places inside that box will be in our data in our database, and our project, our AI chatbot will respond to you from all that data. So this is the code, and this is what I was talking about. All the locations inside this blue box will be covered by our AI chatbot. So here we will drop all the unnecessary columns, and this is the code for it. And we will rename all the columns for clarity, like we cannot have duplicates column. This is the code for it. Now we will safely pass all the full text column over here, and now we will extract our first dictionary from the list. And this is our address column. This is the code for our address column. This is all the code, and this code is here for for unique places. Like for example, we have two places in Lucknow by the same name. So this code is used to remove one of them, and will have only single place. Will remove all the duplicates from the database. This is something a data will look like. And we have also used Wikipedia's library to import data in our code and in our AI assistant chatbot. This is the code for it. This is all the code to import data. And now we will import some images from Wikimedia API using Wikimedia API. This is the code to import images as well. And this is how our data set look like after getting images. I will show you later. And this is used to combine fields for embedding. We have created a new column, combine text, by merging the place name and description in the column. This will help the embedding model to capture both what the place is and the additional contextual details. Like you can see this Buddha tooth, uh, and this is the description for it, and this is the combined text. This will contain other detail. Now step 2 is to load the sentence transformer model. We have initialized all the minimum L6 V2 model from Hugging Face sentence transformer library. This model is suitable for generating dense vector representation of text, and we set it to run to CPU. Uh, the next step is generating text embeddings. This is the code for it, and you can see our data and from where it is imported. You can see the link over here. The fourth step is normalize embeddings. We normalize each embedding vector to unit length using L2 normalization. Step 5 is to create and populate FIASS index. And the step 6 is to run a sample search query. We will search a query, like you can see it can be any query. We have an example over here, beautiful sunset point with scenic view. This is the code for it. You can see our code is working properly. And this is a very important function. Step number 7, we will define a search function. It will take a query from the user and it will return the result to the user. This is a very important function for our AI assistant chatbot. This is the code for it. As you can see, this is running very well. Now we will save our file, index file to dex. This is a retrieval-augmented generation for travel assistant. This is the code. Now we are embedding search function inside our code. This is a query classification. The function uses Gemini to classify user query into one of the predefined types. Now this code is used for prompt generation for LLM. This is the code. It have used some libraries like JSON. This is the code. And now we'll use RAG pipeline to generate answer. It will classify the query based on the query type, relevant context. It will generate a prompt and invokes Gemini. Now it will update the chat history and return the result. This is the code. Now this code is to run a sample query. Like this is how it looks like. You can see, okay, I can help you with some travel destinations. However, the information I have is for Mumbai inside Odisha, India, Jammu Kashmir. It seems you are looking for the places in South India, but I can still give you some highlights from these locations which might inspire a different trip. So this is a query generated by LLM. This is the example of queries and result. And this is two-state structure. It will define the structure for storing user input throughout the planning process using Python type dict. This is the code. And this is the code where the prompt the user for the kind of tour they want. The user will write the prompt like, I want to visit Goa, so I will write, suggest me few best places in Goa. So our Gemini will respond to it. You can also, this is the code where you can ask for the reason. This is the code for starting point. This is the code where you can ask for durations, how for how many days you want to stay. This is the code where you can type your budget, and our tool chatbot will respond to you according to your budget and suggest you places under your budget. And this is the code for specific preferences like medicine needs, food, security, hotels, anything you want. And this is the code for must include places like where you should definitely visit. And this is the code for route mode, like it will tell you like which tour is best for you, which will save your time and distance as well. And this is the code for generating final plans. This is the code. This is the code for handling auto plan. The tour assistant will automatically handle the full traveling plan of yours. This is the code for it. And it will give you the important places. It will include the all the important places where you should visit. This is another query, another code. And this is the simple end node for our LangGraph. It will return the state without modification. This is the function create plan we have used. This function will define and execute a LangGraph based a traveling plan flow using all the user prompts. Okay, this is an overview of all this.
Hello, I'm Harish and I'll be taking you through the rest of the code. So, after doing all of the hard work in creating a graph system, we'll finally get to test it. So, we will call generate_track_answers function because if you want to create a plan, then the function to create a graph is inside this generate_track_answers. So, generate_track_answer is the one destination for all of the things. So, first of all, we send it our query, which is, can you make me a custom plan? Because this is a custom request to make a custom plan for us, Gemini will classify it as a custom request. After classifying it as a custom request, there is an if-else condition that if our plan is custom, then you will create this graph for us. So this is the code for creating the graph. We'll go through this code one by one. So because we have seen what all of this code means above in our video, I'll just explain how to create a graph here. So first of all, we'll define the graph, the basic structure of the graph, and then we'll add our first node. So this is the name of the node, and this is the function which you want to add as a node. So here I have added ask tour type as our starting point for the graph. I have added this function because this is the first thing that our bot should ask about our user when he asks us to create a custom plan. So ask tour type contains options like adventure, hill station. So let's say if I choose adventure, then the next thing it will ask us the region type. So why will this function trigger after this function? Because here I have added an edge which connects two nodes. So think of edge as an action between two nodes. Okay. So the region type is has 5 regions in India: North, South, East, West, and Central India. After selecting one of the region, our Gemini will ask us for starting point. So based on the region that we have selected, we have to choose a starting point in that region. After that, duration of our trip. budget of our trip, and special preferences. Special preferences will contain things like food, let's say. If you only eat vegetarian food, then it will only recommend you vegetarian hotels. Then must include places. So this is kind of an important one. So let's say if you want to do a trip in North India and you definitely want Delhi in it, so you can, that's why this function is for. Uh, our bot will make automatic plan for us. It will include Agra, it will include Uttarakhand, it will include Punjab, but it will definitely include Delhi in that plan because we have asked it for it. Then ask user out mode. So user out mode is, there are three modes in our system and you have to select one of them. So the first one is automatic plan. The bot will create the whole plan automatically for us in that region, in the duration days, in the budget, and in the adventure type. Okay. And the second option is must include places plus automatic plan. So it will, as I've said above, it will create a plan automatically for us, but it will definitely include the places that we have mentioned to the Gemini. The third option is user defined. So what user defined does is it asks us a starting point. After telling it our starting point, it will recommend places, next places near that starting point. And after selecting one of the places, it will recommend next nearest places or the places that you should visit after the current place. So it's kind of you define all of the places that you want to go, but Gemini will create the plan for you from that. The next function is generate route plan. So this is like the final boss where you actually create the plan, where our bot actually creates the plan. And then this end node is kind of a dummy function to tell our graph that it ends here. Okay. So then we'll create an initial state and we want all of their values to be none. And then we'll finally pass it to graph.invoke function. And then we'll return our final state. So let's finally run this code. So as I've said, it should have asked us the tour type first. So I'll put adventure. Now it's asking us for the region. So I'll put North India. Then the starting point, I'll put Delhi. And then it asks us for days. I'll put 5 days trip. And then the budget, it should be 30,000. Special preference, I'll put it none for now because we are testing the basic functionality or of our graph system. Then must include places will also be, I'll skip it. Then I'll choose auto plan because I want the graph to create a whole plan for me. Okay, I'll choose one. So our code also makes a graph, a Google map for us, Google map plan for us. If we try to open it, it automatically plots all of the places that we have to go from the starting point all the way to the ending point. So let's see in our code and let's tally it with our Google Maps if it's correct or not. So first we are going to Delhi, capital of India, and it starts from Delhi. And then we'll do tours in Delhi. We'll go like places like Jama Masjid or Chandni Chowk. And then finally from Delhi we'll move to Agra. And if we see our plan, we are moving from Delhi to Agra. So our plan is correct. And all of these small places like Rashtrapati Bhavan is also added in our graph, in our this plan, Google Maps plan. As you can see here, this is the Rashtrapati Bhavan, and all of these places are a spot, a small spot in our plan. So it's kind of an handy feature that it plots all of the places in our Google Map so that if we are traveling, we don't have to do an extra work. Also, we have also added the functionality of images, so you can see images of every places or some of the places. So here, Red Fort, it has given us a plan of Red Fort. Next is Chandni Chowk. So this is an image of Chandni Chowk. Next, this is the photo of India Gate. And then this is the photo of Humayun's tomb. So so while you are reading your plan, you can also see the image of each destination, which is really good that you are getting that because you, of course, want to know how the place looks like before going there. So it has made a fully functional plan for you for 5 days because we have mentioned 5 days. So this will be the last. You can see Jaipur to Delhi and then departure. So this was the last day. So that concludes our graph system. Of course, there are other functionalities that you can choose and test as well, like auto plan plus must include places and then user defined route as well. Now let's move on to weather query system. So what is a weather query system? A weather query system uses natural language processing to see or find the place name from our query. And once it has find the place name, it also sees that what is our query talking about. If it's about weather, if we are asking about weather, then it will classify that query as a weather query. And it will also uh, extract the name of the place from that query so that we can find its weather. So the API that we are using to get the weather is Open Weather Maps API. We are using this because this is free and it's good. So the first function is extract location from the query. What this function does is uh, what it says in the function name. It extracts location from the query. So first of all, we will load our query in our NLP, natural language processing, which is a spacey model. And then we'll check that if all of the words or which of the words in our query is GPE. A GPE is a geopolitical entity, which is a tuple of all the geopolitical entities, countries, cities, or state in our spacey model. And then if it is a geopolitical entity or basically a place name, it will return that place name. So the next function is get weather info. So what this function does is construct an API URL for the user's location and API key. Then we'll send the GET request to our API and then we'll pass the request and then we'll get the important info from that JSON response. So here I'm only extracting temperature, condition, and humidity in this code. So this code basically will return a dictionary with weather information if successful. And then if the API call fails, it will return an error message. Simple. So here's our API key. And then here is a base URL which we'll be using to get the information of the places. And then we'll be kind of constructing a dynamic link so that we can extract the place name from here. After completing the complete URL, we'll put that URL in our request, and then we'll get the response in our data. And then from that response, we'll extract the location, temperature, uh, description, and humidity. Our next function also, it returns the weather info, the four things that we have mentioned, and if we didn't get, if the place name doesn't exist or there's an error, it will return us this error, which is weather information not available. The next function is process query, which will actually to call all of the other functions that we have created above to find weather related information. So to get the location, we'll call extract location from query that we have made here, the first code, which gives us the location in our query. And then this is error handling, that if the location does not exist, then print this. And then we'll get the weather info. We'll call the get weather info function, and we'll put the location that we have extracted from our extract location from query function. If we get any errors, then we'll print it, and if we didn't, we'll return this function to our rack system again. Tour bot provides us. Now let's move on to test this bot. So this is the last function that I'm calling. I want to visit historical places in Delhi, and it should tell us some of the places in Delhi according to our data system that we have created using APIs. So first is asking us to go to Delhi Ridge, Northern Ridge, Central Ridge, South Lodi Gardens, and Rashtrapati Bhavan Museum. So these are all the historical places that it has given, and it has also given us an image.
We have
So
also made a website called VistaWays. Currently, it is not live, and you can see like plan a 5 day trip for me in Uttarakhand. So this will respond you through Google Gemini. And you can see it have planned a 5 day trip for me. You can see the result. My viewed budget is under 5k. And you can see it is responding you well. And currently this project is in initial stage, and we will add few more options and few more features to our project in future. So that's all for now. Thank you.